Well, thank you very much, and thank you for being invited here, Marco. I come from NIFU in Oslo. I'm going to spend just a couple of minutes to explain what NIFU is, so that you know why I'm here. But mostly I will focus on the other slides, which is about findings from Norwegian R&D evaluations and measuring. NIFU is one of the social science research institutes in Norway. We were located in Tøyen, Oslo, here in the top floor of this building. And I notice sometimes when I'm at the university that people are not so familiar with the institute sector, but we have a very big institute sector in Norway with NORS, SINTEF, NUPI, FAFO, etc. And so we're one of those institutes. We've had a similar center as, how do you say it, QISS? We've just finished 8 years of a similar center at NIFU called QISS. I was one of those people working at that center. But NIFU is an institute that covers the whole process of knowledge creation from kindergartens to innovation and R&D in private companies. So I'm head of research at the section at NIFU called the research system sector, which was obviously heavily involved in this center called QISS. 8 years of funding from the Research Council, where the focus was on research quality, how to measure it, and so on. So when Marco talked, I got a lot of vibes from what QISS was doing. So I think NIFU and QISS, there are quite a lot of, I don't like the word synergies, but we have a lot of mutual interests. So I'm very happy to be here. Okay. Now, one of the things that NIFU does a lot and that we have always done is to work with R&D statistics and to produce R&D indicators, foremost from bibliometric data. And I hope that you're all familiar with the word bibliometrics and know what I mean when I talk about bibliometric data. So what we do is that we are developing indicators and we're using them for different purposes, such as, well, national R&D statistics, but also in evaluations and different analysis. We do a lot of work for ministries and the Research Council. And we also modify the indicators. We suggest to change them, because once an indicator is used for some public purpose, at some point, it might be outdated or it needs modification based on analysis showing that it doesn't work as planned. So, but what I'm going to talk about most here today are the bibliometric indicators. 2 weeks ago, I was at the Research Council. I don't know if any one of you were listening on Teams. It's the annual speech, R&D speech in Norway, due to the launch of the National R&D Indicator Report, which is produced every year by the Research Council, NIFU, and Statistics Norway. So I had a presentation about Norwegian publishing. How are we doing? That's a separate chapter in the report, and I gave some highlights. And I'm going to show you those highlights because they emphasize pretty much what it is that Norwegian government feels are the important things to monitor when we are wondering how are we doing in terms of scientific publishing. So then you get a feeling about what's highlighted from the government perspective. First of all, in 2021, the volume peaked, similar to slides that Marco showed for the whole world. But recently, it's been going down. And many people see that as a problem. We've stopped publishing, we're declining. I'm not so sure. I think this is actually a good thing. Because I don't think this continuous growth necessarily is a good sign. And some weeks ago, there was a huge seminar at the annual conference of Forskerforbundet, the Research Association, about the publication system being under pressure. So if Norway goes a bit down, I don't see that as a problem at all. Now, the problem is when that reduction is because of cuts in the sector, but this doesn't reflect the period where there have been cuts to the sector. That's coming in the next years. So this is because of something else. Maybe it's because of the pandemic. I don't know. But it's not a bad signal in itself, I believe. Another thing that has always been emphasized very much in these annual reports is the fact that Norway has been either on top or among the top countries with highest number of publications per capita. I'm not so sure if that's the right indicator, but it's emphasized that we are publishing a lot. And I think that mentality, that a lot is great, isn't necessarily what we want to have in our country. So the volume is going down, some say that's bad, but maybe it's a good thing to look at this. Norwegian scientists haven't stopped, but there has been a huge change in submission and publishing in MDPI journals and also frontier journals. And this has nothing to do with a general aversion towards open science journals, because you see BMC, slightly growth, +1, it's been quite steady. But a massive drop in MDPI publishing and also frontiers publishing. So if that decline in papers is somehow due to something like this, it's a good sign. That's my feeling. And then in your sector, you removed the publication indicator, tellekantene, right? But the tellekantene are still there in the hospitals who have their own funding system and also at the research institutes where I work. But it's the same in all three sectors. In the last year, there has been a decline in publishing. And you see that your decline has been quite big in percentage, but also the two largest institutions in Oslo and Trondheim have also seen a decline in production of so-called publication points. So this is the volume aspect. Then we always want to know how are Norway doing to the rest of the world by quality. And citation indicators are not identical to quality. It's a matter of scientific impact, so it must be separated, but they're generally used as a quality indicator. Norwegian research is rather well cited on a global level. The red line here, it says 118. That means that a Norwegian paper in general is cited 18% more than other papers for the rest of the world within the same fields of science. So we don't compare cancer papers with physiotherapy papers. The citation numbers are calculated differently in each field. But we're on a high citation score, even higher than China and the United States, and the largest European countries such as Spain, France, Italy, and so on. Singapore, Netherlands, and Switzerland are always on top in these rankings. And we are always slightly below our Nordic neighbors. But what makes me a bit curious about this number is something that I find hard to believe, that, for example, Pakistan has a higher citation index than China and United States. So I think these numbers must be perceived with some caution, to be careful. Yeah. But what's more important with citation numbers, which I'm going to show you later, is how we are doing within different fields in Norway, because that says something about our strengths and where we are not as good as we want to be. Also the same for international collaboration. More is better. That's been the public understanding for about a decade or so now, but something has changed recently. We are starting to question whether it's safe and useful to have all this international collaboration. If you look at this, the one in the middle, 40%, that's all publications. Going back to 2011, 40% of all Norwegian papers had foreign co-authors. Now it's 58. And the top line there, which is natural sciences and engineering, now 70% of all publications involve co-authors from other countries. Especially in that category, you have the large share of cooperation with China. Some years ago, every university in Norway almost, and ministries sent hundreds of people down to China to establish collaboration. That's not going to happen for a long time. And all of a sudden, we are in that situation where the Ministry of Science, on the one hand, says we need to work closely with China because they're the leading R&D nation in the world, and they're also very good at technology. While what's in Norway called etterretningstjenesten, how to translate that, that's like the secret intelligence, they have put China on that list where we should stop collaborating. So we have two different public agencies saying different things. We need to work with them and we need to stop working with them. So who are we collaborating with then? And for these numbers, we've only looked at what we call bilateral and trilateral collaborations, because when Norway are involved in a paper with 100 authors from 100 countries, the Norwegian guy and the Chinese guy haven't made contact. So this is, I mean, real collaboration. And I'm just going to, before that, show you something from an unpublished analysis, which is coming in January. We've done a study on Norwegian collaboration in what's called sensitive technologies. That's like drone research, quantum research. And what we've seen is that Lebanon is a very active partner in Norwegian research. And there's a problem with that. because in Krono, there's a researcher working at Noroff, which is an education institution, not doing a lot of research, who publish a paper every third day. Now remember what Marco spoke about. And one of his closest collaborating partners in these papers is the Lebanese American University. And now, I think last week, there was a new paper in Scientometrics looking at this university specifically. It's very small, but read here. So here's a university that's had a 909% increase in production, which has led to the whole country's growth going up by 102%. And 909% increase combined with a 2% decline in faculty. So I think a lot of these papers are going to be removed at some point. These are paper mills, it's AI-generated research. You can't just believe it. But they actually influence to some extent on these numbers that we and everyone else use when we are looking at how our country is doing in the world. So this is a bit concern. But when we look at the totality, Lebanon is not a main partner for Norway. It's United States, UK, and Sweden. A bit below there, 5.8%, you'll see China. If you look at the four main fields of science, which is humanities, social sciences, medicine, and technology, and natural sciences, you'll see that the UK, Sweden, Germany, and the United States, they're our most important partners in all fields. And then Denmark in 3 out of 4, because there's one country that has appeared on that list, and that's China. In natural sciences and technology, China was our most important collaboration partner last year, and these are for bilateral and trilateral collaborations. So this is real collaboration. And this is something that we have wanted for a long time. I don't know if you know the Panorama strategy, but that's Norway's selection of countries that we want to work more with. Now you see Russia on this list, but Russia has been thrown out, but it was there in the first place. So with China, we have had this massive increase in collaboration, and it stopped. Now this is going to be really interesting to monitoring. On the one hand, some will say we have to keep on getting that up because China is the leading country in the world in those sensitive technologies that we need to improve ourselves within. And some will say it's dangerous to collaborate with China on this thing. So here's a very interesting field where bibliometrics and research policy is confronted with geopolitics. Super interesting. India, the collaboration has just kept increasing year by year. And Russia, the red line here, is practically eliminated from Norwegian research. But there are still papers being produced by Norway and Russia. And I think the Ministry of Science wants it to stop completely, but it's accepted that on an individual basis, you may collaborate with your friend, Andre, that you've known for a very long time, especially in polar research and research in the Arctic. Now, when it comes to China, almost all our collaborations is in natural sciences and technology. And that's because that China is extremely specialized into these fields. China does relatively very little research in medicine, social sciences, and humanities. They're extremely focused on technology and natural sciences. But Norway is also a very specialized country. We just have a completely different specialization profile. So what are we doing in Norway? The green ones, these are the fields where we do comparatively a lot more than the rest of the world. And the red are the fields where we do very little compared to the rest of the world. And the tendency is quite clear. We do a lot in health sciences and social sciences, plus these two that are related to Norwegian special interests and industry. Biology, marine biology, fish and ocean, and geosciences related to the oil industry. But we have very little research compared to the rest of the world in natural sciences and in technology. So there it came on top, okay. This profile is quite similar to what we call the barometerlandene, the barometer countries that we usually compare Norway to with regards to R&D. They are Sweden, Denmark, Finland, Netherlands, and Austria. They have a reasonably comparable profile to this, whereas if you go to China and Asia, it's completely different. Is this a concern or what? I think this is something that needs to be discussed. Marcos, you talked about the autonomy of universities, but the development is that they follow what the students want to study, right? So we're specializing in these fields while the critical technology is not here in Norway. So I'm a bit worried on the day when China says no more collaboration, no more shipping of what we have produced to Europe. So I think this is something that should be discussed. What's our profile? Where are we good? Where are we dependent on other countries, and especially those countries that our government wants us to be a bit more careful with collaborating with? The citation numbers are also reflected in this. Those marked with the red squares, that's where we are really low cited. The green box there, very highly cited internationally. It follows the specialization to some extent. So moving on a little bit, 2 weeks ago, I think, we published this report at the conference of the Research Association. Here's my colleague, Sabine Folscheid, who presented a report about the publication system under pressure. And this has to do, of course, with the volume of papers and the volume of submitted papers. So she presented this report, who Google translated to Castle on Crumbling Sand, a knowledge summary about the scientific publishing system. I would change knowledge summary to science mapping, because what we did was to see what kind of research are done on all these problems that the publishing system is facing. And we worked on this for a while and found this figure. This system is extremely complicated. On the one hand, it's becoming increasingly dominated by a few key actors. I'm talking about publishers. On the other hand, they have this way to organize their activities that resemble these tax fraud systems, where it's important to find where the money goes in the end. So it's complex. But there's a lot of research on this, and the emerging fields are the three ones on the top. Yeah, no, this is, I think we're missing the top here. Okay, I can't see this here. Okay, I can tell you, which were they again? Say it. Oh yeah. I can see it here. Okay, but I can explain this to you. If you look at plagiarism, for example, these are the number of papers on a worldwide basis published each year. So there's about, in 2024, in Web of Science, there were 17 papers looking into plagiarism. So this is like a field which is studied pretty steadily every year. But there are three emerging fields, and one of them is paper mills. Last year, there were 122 papers on paper mills. Going back to 2015, there were hardly any. So that's like an emerging field to study. Also, what's called questionable author practices and how AI impact on research quality. That's the three emerging fields. And then you have these. And what's interesting is that those countries with the most rapid increase in publications are not involved in any of these papers. So this is typically European papers and American papers studying questionable publication practices. That's a bit of concern, I think. So we are very interested in these things, but some of the countries that produce some of the problem, to be honest, are not. So at NIFU, we have been involved in several projects and processes and systems using bibliometrics into funding of research. And you all know publication points and telecom system, right? That's one of them. Typically measuring publications. But I want to talk about something which I find interesting, because there are many other aspects or phases of the research process that's worth empathizing and that could be rewarded in some way. And the Ministry of Health has actually done something about this. Because in clinical medicine, if you want to produce papers, you need patients. And to be the coordinating of a clinical study is highly time-consuming. It costs a lot. And what the people from clinical medicine tell me is that usually when you do a clinical study, you get one paper. Meanwhile, the people at the lab doing biomedical research can produce a lot based on studying cells. So they felt if you want the hospitals in Norway to keep on having patients involved for clinical studies, we need some kind of reward system. And the ministry agreed, and NIFU was involved in making a so-called clinical trial indicator. This is the national system. You don't know this, but this is the funding system for hospitals, and each year NIFU makes this number for the ministry. So the hospitals in Norway, just like universities, each year there's a R&D funding provided to them based on what we call research points, which is equivalent to the tellekantene. Now, traditionally, we calculated those points based on publication points, bibliometric data, PhDs, and external funding. But recently, the Ministry of Health has said that, okay, we're going to distribute 85% of the funds based on these 3 indicators on the top. The rest, 15%, will be distributed based on number of patients you have included for clinical trials and to what extent you have taken the coordination role. So it's a way to reward those hospitals that really take a active part in making this study possible to carry out. This is an indicator put on the universities that they actually felt was okay. We are rewarded for something that we find very useful and that we were previously not rewarded for. So it's a good thing. Next up is an innovation indicator. It's much more complex. I'm not so sure how happy they will be about it, but the Ministry of Health wants it to be tested out in a similar way to this. So 4 open questions at the end. How do we measure research activity? How do we evaluate its quality? Or any other input process or output factors decisive for good research, like the Ministry of Health did with this clinical trial indicator. Also, relevance, societal or scientific value. I don't know if the current set of indicators used can provide good answers to all these things. And we are always looking for new and better indicators. But please do not suggest altmetrics, Twitter and Facebook and so on. I think that's a terrible solution, even though we want research to be widespread and reaching a larger audience. So that's the end of my presentation. I just tried to show you a bit about what indicators we are typically using when the government wants to know how are we doing here in Norway and what they emphasize when they want to measure and evaluate research. And I had a question at the beginning of my presentation. I haven't answered it and I won't, but maybe this gives some room for some reflection and questions. And for Marco and the others at QISS, maybe you'll see something here interesting that makes a collaboration between NIFU and QISS worthwhile. So thank you very much.